Welcome back in the final installment of SANWA Week. Hope you guys are enjoying it. It's a lot of fun. I'm really happy that I can bring it to you on the channel. So today we're looking at an analog multi-tester, as SANWA likes to call them, the YX360TRF. Cool looking box, and no word of a doubt, they let you know that indeed it is
made in Japan, yeah.
But besides that, what do you get in the box? Well, besides the multimeter, or multi-tester I should say, you don't get much. You get this handy little carry-on strap, because you can strap it to the top of your SANWA and keep it nice and handy. Finally, you get a manual as well. Well, I'm calling it a manual. It's really a fold-out piece of paper. Yeah, it's not much. But, yeah, the days of getting these big, thick SANWA manuals seem to be going the way of the dodo. But anyway, at least you get something. And finally, of course, you get the gorgeous SANWA Multimeter right here. And look at that. It has that nice protective cover on top. Now, there's a little clip at the bottom here. You just simply remove it. And voila! Who's your daddy? Yes, look at that. One gorgeous looking analog multimeter, courtesy of SANWA. Does not come with a tilt stand. That kind of sucks. Well, guess what? The back cover doubles as a tilt stand. Yeah, simple as that. Away you go, bada boom, bada bing, bada bang, and you now have a tilt stand. Really nice attention to detail with this SANWA, I have to say. Really nice plastics, molding. The body looks top notch. And yes, those leads are captive. In terms of the actual body or corpus itself, yes, it is all plastic, but it is a very high grade, top notch, good quality. You can't really do much better than this. No, very, very nicely done. I don't see one defect in the mold on this meter. It is really, really top notch. SANWA test lead, boy, that is high quality right there. Really, really nicely done. Gold plated. Beauty. Now, unfortunately, this meter does not come with any continuity feature. Yes, we have no continuity. Yeah, we have a really nice 0 ohms adjust. You can one thumb it here, no problem, or you can use both fingers if you prefer, but very, very nice. Take a look at that rotary selector switch, shall we? Starting off at the, I'd say 4 o'clock position in the off. Resistance, up to 200 mega ohm. DC current, up to 250 milliamps. DC volts, up to 1000 volts. DC volts, null, up to 25 volts. Plus or minus. AC voltage up to 750 volts. Capacitance. SANWA did a really good job on the actual meter itself. The scale is very, very nice. A lot of readings here, so you have to sort of get accustomed to it when you first get the meter. Make sure you know what you're looking at when you're taking up those measurements. Resistance, voltage and current. AC 10 volts. Capacitance, null, plus or minus DC volts. Microamps, milliamps. HFE. Doing our DC accuracy test, we should be looking at 5.00 volts, and we're awfully close, but we're not quite there. You can tell that's the indicator. We're between the 4 and the 6, and yeah, we're just shy of that 5 mark. Alrighty, we're going to do a quick voltage showdown, and I've got Mr. PC 700 on the left. And on the right, an oldie but a goodie is the triplet Model 630NA, another analog meter, classic really. And of course, the star of the show, the Y360TRF. So we're sitting at 10 volts right now. Now I have both of the analog meters set to, well, on the SANWA it's set to 10, and on the triplet it is set to 12. But you can see in terms of the actual reading, it is pretty darn close on both of those. Let's take a look here. Pretty well spot on for the SANWA at 10. And for the triplet, yeah. Spot on as well. Now that's on a bit of an angle because this triplet is so darn big, but yeah, it really is there. Now as well, both of these meters have that nice mirror inlay, so when you are making a reading, you really want to sort of look right on at the needle through the mirror just to get a true reflection of where that needle is, because it's all about accuracy with these analog meters. Alrighty, so I moved the selector switch on both of the analog meters now up to a higher range just because we're going to be taking the voltage up. So now we're still sitting at 10 volts, and you can see pretty close but not spot on for the SANWA. And same thing for the triplet, we are a little bit off in that lower range. Okay, here we go. Taking it up. Let's go to 16 volts. 15.99 for the PC 700, and Wow, it is pretty darn close. In fact, I'd say that's just under 16 volts on the SANWA. And as well for the triplet, oh, so close again. Yeah, just a little off. 20 volts even according to the Siglin power supply. And look at that, Mr. 700. This is one accurate digital multimeter, let me tell you. 20 volts, oh, it is just a little off. Oh, it's showing us about 19.2 on the YX360. And for the triplet, we are looking at, oh, just the same thing, about 19.4 volts on the triplet. Okay, up and away. We're gonna go to 40 volts even. 40 volts for the PC700, 40.01 actually. And you can see that needle is definitely coming up. We are just shy of that 40 marker on the 360. And for the triplet, yeah, I guess its age is showing here. It is definitely a little slow and a little low. Coming up is around 38 volts on the triplet. Okay, you know what? Let's just max it out right now. So it is maxed right now to 64 volts. So now we're maxed out at 64 volts. I have moved that range selector one more time just to bring it up to the 250 marker and the 300 marker respectively. So 64 volts is what we're sitting at. Look at that beautiful SANWA PC700, spot on. And neither of the analog meters are there. The SANWA is showing us around 62 volts. The triplet is even worse, probably around, oh gosh, about 58. So yeah, a little bit disappointing actually. But hey, it is what it is. In this case, the winner is, yeah, you guessed it, Mr. Digital. Good job. Next up, we're going to take a look at resistance. Now, first thing you want to do is definitely use the zero adjust feature and make sure you are zeroed out. So let us see how we stand. And oh my goodness, well, you know what? That is pretty well spot on. So no need to play with the zero adjust for resistance right now because it is right on the money. Let's start off with our good old lab resistor, 100 ohm. Let's see how good it is. And you can see that dial is moving up, and let's just get in there for a close look, shall we? So 100 ohm. Now let's look at that scale. You can see right at the top. And yeah, we are just shy of that 100. Close but no cigar. So yeah, I already have the decade box out right now, and let's take a quick look. 100K is where we're at, and yeah, we're pretty close. Just over 100K, so yeah, not too shabby. All right, let's take it up to 300K, and yeah, that is pretty well spot on. Let's try 500K. Just a tad over once again. Okay. All right, let's try 1 mega ohm. And yeah, pretty well spot on. Let's try 2 mega ohm. Oh yeah, looking good. Okay, capacitance is next. Now, this really doesn't have a huge capacitance range. In fact, yeah, it only goes up to 10 microfarad. I know, not very high at all. 10 microfarad. Come on, SANWA. Anyway, you know, I'm going to try it out just because it's there. But at least 100 microfarad you would expect, especially if you're working on, let's say, a TV, you know, I mean, I don't know, 10 microfarad. Anyway, all right, so here we go. I'm going to start things off with, well, you guessed it, a 10 microfarad capacitor. Now, the different thing with the analog is for an electrolytic like this, you actually do things in reverse. So the positive lead is going to actually go to the negative on the capacitor, and same for the negative lead is going to go in the positive for the capacitor. So it's the reverse of what you do with a digital. Well, before you take your measurement, you want to make sure that you null out your leads. So in capacitance mode, we're going to put our leads together, and we should hit 0 on that scale. Now, where we're looking right now is here at the bottom. So we should see right on that 10, and we are a little bit off. So let's adjust that. And that looks a little better. So we'll take them off again. And in capacitance, are we on the 10 marker? 10 microfarad? Yes, we are. So you can see now we are zeroed and ready for action. Okay. So once again, it is a 10 microfarad capacitor. Now, the other unusual thing with this meter when you're measuring capacitance is it's going to hopefully find the value of that capacitor, but then it starts to discharge right away. So it's gonna you can see that needle go down, and you'll see what I'm talking about shortly. So let's just hook up our capacitor. Remember, we're doing it opposite. Positive on the negative, negative on the positive. And here we go. Now, we didn't even get to the 10 microfarad, did we? Now the needle is going down because it is discharging, and that's normal. But, yeah, it didn't get to the 10. We're going to try one more time. We should be going right to the end of that 10 microfarad marker. So let's try this one more time. And, oh, wow. It's coming up shy. It's about 5 microfarad, which is, Now it's discharging, but you know what? Let's get a second opinion. Okay, so the X-Tech LCR meter is telling us 9.3 microfarad for this cap, so it is not bad. I did try it on another LCR tester as well, and it gave me the exact, well, pretty close to the exact same reading. So it's around 9.5 microfarad in that range. But we're not getting that with the SANWA. It's not even coming close. So, So this is a 3.3 microfarad we're going to try, and it should end up around there. That's where we want to see that needle. Here we go. Now this particular cap doesn't really matter which way I'm pointing it, so. And that's better. So we did get our 3.3 for sure. I'll get in a little bit closer again. Once again, we want to see it around there. Okay, so let's try again. 3.3 microfarad. Wow. Not liking that, not liking that at all. Okay, we're going to try it one more time. 3.3 microfarad. Oh my God, what just happened? And yeah, that just went all the way to the end. What the heck? And that is a 3.3 microfarad. Let's just try this one more time. Okay. Well, I think we have a little bit of wonkiness in capacitance land. Unfortunately, with the SANWA YX360TRF, the capacitance function seems to be a little wonky. Oh, really disappointing. Looking at AC voltage right now, 120 volts, and pretty darn close. In fact, I'd say that's pretty well spot on, really. 120 volts AC, no problem. So the last feature we're going to look at is the DC volts null, plus 25 minus or plus minus 5. One thing you have to do once again is make sure that you're going to zero adjust before you use it. Now we are in DC volts plus minus 25, and you can tell we are pretty well spot on that zero, and that's where you want to be. If you're off, once again, you just take your zero adjust and just adjust it accordingly to your right on the marker in between. So yeah, looking good. So we're going to take a quick measurement of this 9-volt battery and just see where we are with it. So let's try it out first with the PC700. So we're sitting at 9.4 volts. Let's just hold that reading. And we're going to try the same thing now with our analog meter. Once again, we should be about here on the meter. And yeah, looking good. Now, if I reverse the leads on the battery, we're going to actually go in the opposite direction. And there we are, negative 9 volts. So that voltmeter with the center zero, the null meter feature is definitely cool. Definitely brings up the accuracy depending on the circuit you're testing, and can come in very handy. Okay, let's take a look on the inside and see what SANWA has done, good or bad, to this analog tester. Alrighty, Aphrodite, we are in the SANWA, and looking at, first of all, the reverse side, yeah, no shielding. All right, let's start off with that fuse, shall we? That is a 500 milliamp, 250 volt glass fuse. Glass fuse. Ugh. Anywho, one thing to take note of, if your fuse is blown on this meter, it will affect you to all over the place. You won't be able to take capacitance measurements, and your null feature as well will not work. So if you're having any issues at all, check your milliamp fuse. Chances are it's blown. You can't help but notice that big honkin' resistor here. That's an 18 ohm 2 watt resistor, and that's there basically for protection if you do something silly like perhaps go from resistance to volts. That way you're not going to blow the meter. And maybe one thing I'm not impressed with is this is actually just paper that is on top of that needle. You could really pull it off, but it's, you know, very cheesy chintzy, and on a SANWA I'd rather not see it. But we do have a really nice brass threaded insert. Look at that, gorgeous. And that's the one screw we have to remove the back cover. One solitary screw goes into that brass threaded insert, but at least it's threaded. Very nice. Now we've moved up the line. Something interesting you can see. It looks like there used to be, or this molding perhaps was used for continuity feature on another meter, but that does look like the cutout for a piezo or speaker of sorts. But anyway, they negated this continuity feature on this meter. That's a shame. Powered by two 1.5 volt batteries. Taking a look at the other side of the meter here, we can see that ohms adjust, the potentiometer here. Oh, you know, not uber high quality. So once again, you know, now you have to understand this is not a $300-400 meter. This is probably about 90 to 100 bucks. So it is not, you know, an A-class style meter, but nonetheless, I just expect a little bit more from SANWA. Not much else on this side of the PCB. We're going to take it apart a little bit further. The two test leads themselves are soldered into the back of the PCB, and we should see them on the other side, but there they are. Pretty decent gauge wire as well. Yeah. On the other side of the board, here we are with those selector tracks. They do appear to be gold-plated, which is always a good thing, and nice spacing as well between them. Now, one thing I'm not impressed with, wow, look at that messy soldering job here. This is for the fuse, but oh God, look at that, you know. Not good at all. Yeah, holy moly cannoli. So anyway, nah. A lot of flux, a lot of residue. They didn't really clean anything. We still have a lot of debris as well here on the PCB. So, nah. Looks like we have a little bit of a diode clamp going on. Now this long filament as well, I believe that is for the capacitance range. Yeah. Finally, oh, there we are again with this. Oh, wow. Again, look at the schmutz here. Can we call it schmutz? Is that a word? But you know what? A lot of schmutz. SANWA, why are you not doing a little bit better job here in terms of the Q&A on this? This really should have been cleaned before it left the factory. I mean, hey, this is part of your ohms adjust, so it's very sensitive, and you really don't want to have any gook at all. Oh, yeah, not good. Not good at all. Finally, we have the battery clips for the AA batteries soldered here on the back. Let's take a look at the back of the selector switch here. The pads themselves don't appear to have any plating on them at all. So in the long term of wear and tear, that's probably not a good thing. Something else as well that needs pointing out is there is no grease, dielectric, nothing on this selector at all. Yeah, it's too bad. It really should be greased to some degree. I don't see any grease at all on the selector switch or anywhere for that matter. So, yeah. Quite amazing. This is the best-selling meter SANWA has ever produced. Yes, you heard me correct. This is SANWA's top-selling meter. Unfortunately, I'm just not a big fan of this one. There just seem to be a lot of little things that added up to a not-so-great analog experience. Let's start off with the good points, though. It's definitely an affordable meter, not super uber expensive, and really well within the price range. Exterior build quality is absolutely top-notch. SANWA once again hits the nail right on the head, making an analog multimeter that is gorgeous to look at and just an all-around top-notch design. That display is big, bold, and very verbose. You won't have any trouble reading those scales. Once again, good job, SANWA. And let's not forget those fantastic test leads. As always, SANWA test leads are some of the best, and these ones are no exception. Unfortunately, it's not all a bed of roses. In fact, there's a lot of things that are just not that great. Let's start off with that really poor capacitance slash buggy capacitance. Yeah, not very useful, and honestly, kind of useless. No continuity, that really sucks. I have to say, I do love continuity on any meter, digital or analog, and I was really expecting continuity on this one. Let's talk about the interior build quality. Wow, that was a major fail in this case. A lot of flux residue all over that little PCB, and I'm telling you, that zero adjust ohms pot was absolutely atrocious. And don't even get me started on these glass fuses again. Wow, what is up with that? Anyway, input protection wise, this thing really doesn't have much. As venerable as this meter is, I have to call it like I see it, and in this case, I don't see it that great. The SANWA YX360TRF analog multitester gets a disappointing 2.5 out of 5 stars. Hey, thanks for watching this review, everybody. This is it, the end of SANWA Review Week. It was short, it was sweet, but it was so much fun, and I'm glad you guys were here for the ride. Don't forget, if you saw that SANWA logo during the review, leave a comment below. First one that gets the time right is automatically entered to win a SANWA digital multimeter in March. It's gonna be a lot of fun. It's gonna be a live draw, and you know what? I might even give away something else at the same time. Thanks for watching this review. It was a lot of fun. Till the next one, keep on testing.